I apologize if this is going to be a long video. Okay, so on Friday, your activity from Desmos, which hopefully you guys work through and you realize some of the little mistakes you may have been making because, like, it wouldn't let you submit unless it was completely right. If not, that's okay. We'll revisit some of that here. So, the activity from Friday was just meant to show you how we've come, like, why the sum and difference trig identities for sine and cosine are what they are. And I would say that it would be awesome if you guys could add these to the ones you know by heart. But the other ones you really need to know by heart and be fluent with are the reciprocal, the quotient, and the Pythagorean identities. If you know how to use those, you use those more often than not. This is the sum and difference. You'll use in calculus just a little bit every once in a while to um, derive new formulas. And when you understand that in calc, you'll realize, man, Mr. Rodriguez is so good at his puns. You don't even see them coming. All right, but let me tell you how I've not was taught, but like someone showed me a neat way to remember the sine and cosine. So I'm going to condense the sine and the sine ones into both addition subtraction. So the sign of the operation sign above and the operation sign below represent which ones go with what. So imagine that you have two people that are maybe going on that are planning going on a date. Sinbad and Cosette. But they're kind of shy, so they're going to go on a double date and they're going to go to a diner and they're going to sit in a booth. So Sinbad really likes Cosette, and Cosette is kind of being a little too nice. So if I think about that situation, here's the story. So if Sinbad is able to choose the seating order for the diner, since he's really interested in Cosette, ideally he would have Sinbad and Cosette together, and their buddies kind of sitting together on the other side as well. So Sinbad's buddy and Cosette's buddy. Right? So that way, you get to sit next to someone that you like. However, if it's up to Cosette, well, Cosette doesn't want to, like, she's being nice, so she'll go on this date. But she's trying to minimize the mixed signals that she sends. So if it was up to her, it would be Cosette sitting next to her friend, while Sinbad sits next to his friend. And let's talk about the operation signs, because I don't know if I like the way I did it. So if I'm trying to add two angles inside of a sine function, I'm actually going to subtract both of these. And if you did the activity on Desmos, that makes sense why it's a subtract sign. However, if I'm trying to subtract to find a difference, then I'm going to add these, because that's kind of using the even-odd identities. So that's the story of how I remember the sum and difference trig identities for sine and cosine, courtesy of Sinbad and Cosette. Hopefully you guys don't find it offensive that anything that I said, but that's just the way I have to remember it. Because, hashtag 2020, because I could have just said no at the very beginning, and Sinbad should just accept it. Move on. Okay. So, using these ideas for sine and cosine being what they are, I'm going to use them to show you how to derive tangent. So, I'm going to try to prove that tangent of x plus y should equal tangent of x plus tangent of y over 1 minus the product of tangent of x tangent to y. There's no funny story for tangent, so if you guys can come up with an awesome way to remember the tangent ones, I would love to hear it. Okay. So the way I'm going to start this proof off is by trying to manipulate the left side of the equation. Because I know that tangent can be thought of as a as a quotient of sine over cosine, then I can express this as sine of x plus y divided by cosine of x plus y. So that's what I have on the left side, and give me one sec. Sorry, I just got the phone call letting me know that I got an email, but my computer dinged, so that's how I know I got an email from the school district. Okay. So where was I? Yes. So I took this and I converted it into that. But I ultimately want it to come out to this. So I have to do quite a bit of manipulation. So I am going to go ahead and do my substitutions. I know what sine of x plus y should equal, and I know what cosine of x plus y should equal. So I'm going to rewrite that as sine x cosine y plus sine y cosine x over cosine x cosine y minus sine x sine y. So that's currently what I have for this right here. So in order to try to simplify this, I need to figure out where to get the tangents from. So as a result, what I'm going to do is I'm going to divide everything by this term right here. And let's talk about why I would choose to do that. If you notice, in the denominator, you have this 1. So this 1, I'm guessing, has to come from that cosine of x, cosine y. So since I want to simplify that, I'm going to go ahead and divide all that I currently have, by that value. All right. Does that make sense, like how I kind of developed that vision, knowing what I'm working towards? So if I divide everything by that, that means in my numerator, I have sine x cosine y plus sine y cosine x cosine x cosine y minus sine x sine y. And hopefully as I'm writing this, you can kind of maybe visualize what some of these cancellations will look like. And actually, let me go ahead and split those up into two fractions while I'm at it, because it's just going to be easier to do it right that way. Cancel. 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 And nothing cancels, but that's okay. So if I take a look at what I have left now that I've divided everything by that cosine x cosine y, this right here is sine of x divided by cosine of x. So that just becomes tangent of x. Sine of y divided by cosine of y is tangent of y. So now I see that I have that numerator. Divided by, well, this actually simplifies into a 1. If you divide something by itself, you get 1. And this last one, well, it doesn't nothing cancels out. However, I can kind of treat this as a multiplication of two fractions. So I can think about this as a cosine of x times sine of x divided by a cosine of x, which should give me a tangent of x. And then I can look at it as multiplying a sine of y divided by cosine y, which is where that tangent of y comes from. So as a result, if I look back to where I started, I'm pretty sure I got to where I was supposed to get. Yep, tangent of x plus tangent of y divided by a 1 minus tan x tan y. Proven. So, if that's what happens with addition, let's talk about what happens with subtraction. And I'm going to take a very similar approach to what that Desmos activity did. I'm going to think about it as tangent of x plus a negative y. If I keep in mind that tangent of a negative angle is equal to a negative tangent of that positive angle. All right. So since I'm adding, I'm just going to go ahead and replace all the tan y's with a negative y. So I should have tangent of x up top, 1 at the bottom, currently have minus, currently have plus, tangent of a negative y, tangent of x, multiplying a tangent of negative y. All right. So if I do this, then I can go ahead and employ this identity now. Oops. All right. That means I have tangent of x minus a tangent of a positive y now in my numerator over 1. Well, this negative and that negative, double negatives give me a positive because I'm subtracting a negative amount, a negative quantity now. So now that'll turn into a plus, and you get tan x tan y. So that's what the difference equation for tangent should be. Okay. Yeah, so like I said, this might be a little long because what we're going to do is we're going to go ahead and we're going to work with these identities. We're going to prove a couple things. So I'm going to show you a very difficult example. So that way you guys can say, okay, Ms. Rodriguez will give me easier practice. So let me go ahead and reset. All right, so I've rewritten the identities that we should know for the sum and differences, and in the purple, we have an identity that we need to prove. So let's go ahead and get started. The first thing I would want to do and recommend you do is I know on the right side, I know on the left side, I'm going to use the sum and difference identities in the blue because it's right there. So the goal is once I do that substitution, I have to manipulate them and turn them into the right side. But in order for me to kind of see what I'm working towards and help inform my decisions for what I would want to do, I'm going to break this down into sines and cosines for everything, both left and right. So that's going to take a lot of writing. All right. So for the numerator, we have sine of x plus y. So according to the blue equation, since I'm adding, I'm going to add the products up top. So it's going to be sine of x cosine of y plus sine of y cosine of x. And that's going to be over. Now in the denominator, I'm subtracting. So according to this bottom sign here, I'm going to subtract the two products. So sine of x cosine y minus sine of y cosine x. All right. And I want to figure out what am I working towards on the right side. So I know cotangent is the reciprocal of tangent, which is also known as cosine over sine. So I know I should have a cosine of y over a sine of y plus a cosine of x sine of x over cosine of y sine of y. Oops, I said y. Minus cosine x sine of x. Right? So that is what I'm working towards. And now it's I can kind of look at what I have and think about what's my next step going to be. So I'm going to take a look at one thing at a time. All right. If I look at the sine of x cosine y, both top and bottom, they turn into a cotangent. And if I notice, it's in terms of y, so somehow the x has to disappear. So I can tell that at some point I should be dividing by a sine of x on both sides. Because that's the only way I can get those sines of x's to disappear so I can do that. Oh, wait, I get an extra bonus. Okay, and I also know I need a sine of y in the denominator, so that means I need a sine of y as well. So just by breaking it down like this and thinking about what's still left, I can kind of work backwards to see what I would have divided by, and now I have to confirm my work. So to be clear, I think I need to divide the left side. All those products are being added or subtracted by a sine of x sine of y. Because if I'm correct, I should get simplifying to match what I have on the right side in the black. Okay. So if I did this first one right in the first numerator, I should get the sine of x's to cancel out. And I'm left with cosine of y over sine of y, which I do. Same thing happens. Okay, so that's where the cotangents come in. Now let's see the other parts. The sine of y's cancel out, sine of y's cancel out. So you have cosine of x over sine of x, cosine of x over sine of x, and those are indeed cosine of x's. That's where the plus comes in. That's where the minus comes in. Wow, that was really easy. Okay. Yeah, so whenever you see how the simplifying goes, like that sine of x, sine of y, I wouldn't have thought of that in a million years unless I broke it down this way. So it's very important that you try to do some of these substitutions in terms of breaking down sine and cosine to see and try to figure out what you would have divided by to simplify in such a way. All right. And I'm going to show you one more just to really see why A. Cover your, well, I guess I shouldn't have said A. CYB, cover my butt. So we're going to work on an example where instead of just working strictly with these expressions, these trig functions, not just x and y as the inputs, but if I give you, let's say, an angle, how those would look. And this is going to require knowledge of your unit circle. So when you see me pull out these numbers super quick, that's how I'm doing it. All right, let's say that I was asked to solve this and to prove that it equaled something. I don't know what it equals yet, but you will have a problem like this where they just want you to verify the identity and it's going to look something like this. So the first thing I notice is that it's sine, and I recognize that pi and x are acting as angles. So I'm going to go ahead and use my sum and difference identity. And because they're subtracting, again, I'm going to do subtracting. So I'm going to go ahead and do a little substitution. This is going to act as the x, and this is going to act on the y right here as the first and second angle. So it's going to be sine of pi times cosine of x minus sine of x times cosine of pi. All right. So now I just have to do a little bit of evaluation. I know that sine of pi is 0. So it's 0 times cosine of x, which is just 0 anyways, minus sine of x, cosine of pi is a -1. So negative times negative makes it positive. Well, so it turns out this should equal sine of x. Now that's really quick, and that's all you really have to do with these. Whenever you have an angle, just plug it in, evaluate it. They tell you to multiply, so go ahead and multiply them out. And then add or subtract whatever you have left depending on the situation. Thank you for coming to my TED Talk.